Hello everyone, welcome to today's tutorial. So in this tutorial we're going to be discussing how you can differentiate these functions that you're seeing on the screen here. And then if you have not yet subscribed to the channel, make sure that you click the subscription button and don't forget to click the notification button so that you don't miss out the videos that I'm going to be posting. And if you have any questions, feel free to contact me on any of these lines on the screen. Alright, so let's quickly begin to solve. So the question is, find the derivative of the function. So what we can do to solve or to find the derivative of these functions, to make our work easier, we're going to be equating them to y. But I'm going to solve for both cases where you take it the way it is with f of x and even the one for y. So I'm going to start with the one where we're going to equate the expression to y, so that first you understand the concept before we deal with it the way it is. So I'm going to say let y be equal to 4 to the power x, and then from here we're going to introduce ln on both sides since it's difficult for us to differentiate 4 to the power x. So I'm going to introduce ln on both sides, which will be ln 4 to the power x. And according to the rules of logarithms, if you have something like log 2 to the power 3, this can also be written as 3 log 2, meaning this 3 can drop down, can be written this side. Okay, so this is what we're going to apply here. So this this power x is going to be dropped down here. So we're going to have ln y is equal to x ln 4. So ln 4 is just a number. It's just like any number. When you type this on the calculator, ln 4, the calculator will give you a constant. It's just a number. So we're just going to assume that this is just a number. Okay, it's not an assumption, it's a number in short. So having ln 4 is just the same as having 2x. So when you say differentiate 2x, the derivative of 2x is simply just 2. So this is what we're going to have. So differentiating this part is not an issue. Let's first differentiate this part. So differentiating this part is also we're going to follow the rules of logs. How do you differentiate logs? You differentiate the function that we've been given. So when you differentiate y, you're going to get 1 as your solution. But remember how we differentiate implicit functions. When you're differentiating y, you always have to okay, well, let me start first by explaining the derivative of a ln. So when you're differentiating ln, you first differentiate the function, which in this case is y. When you differentiate y, you're getting y, and then you divide by the original function. The original function in this case is y. So when you differentiate y, you get 1, divide by the original function, which is y. And then if you are differentiating y implicitly, it means that you always have to add dy dx this side. So we're going to have this being equal to. Then when you differentiate this expression, remember what I said. When you differentiate certain expression there, it's just the same as differentiating this. If you want, you can use the product rule. When you differentiate this using the product rule, you still get the same answer as what I'm going to get here. So the way I differentiated 2x to get 2 is exactly what I'm going to do to differentiate this expression. Meaning I'm going to have ln 4 as the answer here, because x has the power 1. 1 minus 1 is 0. X to the power 0, the answer is 1. 1 times ln 4, we're still going to get ln 4. So dy dx and dy dx is simply just going to be equal to, when you cross multiply here, we're going to have y ln 4. So this, if you want, you can erase this on top. Like I said, for this situation there, if you have ln a to the power b, this can be written as b ln a, which is also the same case. If you have this expression, this can also be written in this format. So if you want, you can write the value of y here. The value of y is simply just 4 to the power x. Even here, if you want, you can write it here in advance, or you can first take the y as a power there. So you're going to have something like this. Dy dx is equal to ln 4 to the power y. This is what I was saying. What is in this format can also be written like this. So this is what I've done. I had y this side, I've taken it up there as a power. So while there is y there, I can replace back the value of y, which is just 4 to the power x. So my dy dx will therefore be equal to ln 4 to the power 4x. This is what we're going to have as our dy dx. Let us quickly move on to the next one. Or before we do that, let us use the same f of x without using y. I like using y because it's easier to write. Yeah. If you want, you can just differentiate it exactly the way it is without introducing another letter. So let's use f of x before we move on to the next question. So we have f of x is equal to 4 to the power x. So differentiating this, we first introduce ln on both sides. You can either introduce ln or log. It's still the same. So we say ln 4 to the power x. Then this, when we differentiate, or before we differentiate, we can drop down the x first. So we're going to have ln f of x is equal to x ln 4. So this can now be differentiated. So when you differentiate this, you're going to get so when you differentiate this, the first part here, you're going to get 1 over f of x, and then times f prime of x is equal to, this side you just get ln 4, like I explained. So on this other part, we can cross multiply to leave f prime of x along this side, which will be f of x multiplying to ln 4. So as you can see, we can still raise this f of x to be the power of 4 there, meaning f prime of x will simply just be equal to the ln of 4 to the power f of x. So this is what you're going to have as your expression for f prime of x. So while there is f of x, you can replace back the value of f of x, which is 4 to the power x. So f prime of x is simply just be equal to the ln of 4 to the power 4x, 4 to the power 4 to the power x again. Yeah, this is the expression. Alright, so let's quickly move on to the next one. So even the next question, we do the same thing. Okay, almost all the questions here you do the same thing. So I'm going to be a bit fast because we're just going to be going through the same procedure. So like I said, I like using y, so I'm going to say let y be equal to 3 to the power, I'm answering this one, 3 to the power 4x. So introduce ln, or let me introduce log in this question, so that at least you get used to both. So you can either introduce ln or log, or for the sake of understanding, let me just continue with ln. Might end up confusing you. So ln y is equal to ln 3 to the power 4x. Okay, so we have ln y this side, and then we say this is equal to, drop down this, we're going to have 4x, then you have ln 3. So differentiating this expression will give us 1 over y dy dx is equal to, differentiating this other function on this other part, we're going to get so differentiating this other part, we're going to get 4 ln 3. Yeah, so we can cross multiply to get dy dx, which will just be 4y ln 3. So we can simplify this further by writing our dy dx as ln 3 to the power 4y. So dy dx is simply just equal to the value of y in this case is 3 to the power 4x, so we can replace it back there. 3 to the power 4x. So don't make a mistake by multiplying this 4 and that 3. No, you can't multiply those two. So this is the expression. So you conclude by writing f prime of x is equal to the ln of 3 and then 4 to the power x. let's quickly move on to the next one, this one. So on this other one, I'm just going to use f of x. So you can use f of x or you can introduce y, still get the same answers. But if you introduce y, make sure that your final solution is having f of x, not y, and not dy dx. Okay, in this case we have y, so meaning there's no need of us introducing y again. I didn't see the question. Yeah, so in this case we already have y, so there will be no need of us introducing y. So we can just say y prime or dy dx, still the same. So I have y is equal to 5 to the power negative 4x. This one is straightforward. This one is just the same as this one, so I'll skip this one. You can solve it and send me the solution in case you're doubting your solution. So let's try this one. So we have y is equal to 6 3x minus 4. So we can introduce ln, or before you introduce ln, if you want, you can first write this as, I think the best way is just to introduce ln so that the power comes down. So when you introduce ln, we're going to have ln y is equal to ln 6 3x minus 4. So we're going to have ln y is equal to 3x minus 4 times ln 6. So differentiating this part, we're going to get, so when you differentiate this part, we're going to get 1 over y dy dx. Then this other side, if you want, you can first open the brackets by multiplying ln 6 throughout the brackets there, meaning we're going to have 3x ln 6 minus 4 ln 6. So this one is a constant. This one is just a number. It has no variable, in short. There's no x in this expression. So meaning when you differentiate this, you just get a 0 as your answer. So let's quickly just differentiate this part. That's the only part we're going to differentiate. So differentiating this part, there is x to the power 1 there. This will just give us 3 ln 6 as the answer, because x is raised to the power 1. So if x is raised to the power 2, you can multiply this 2 times 3 to get 6. So in this case, x is raised to power 1, so there's no need of us multiplying. So let us just differentiate it directly. Okay, we can multiply this 1 times 3, which will still give us 3, and then 1 minus 1 to give us 0. X to the power 0, the answer is 1. So you can write 1 there, and then we say ln 6, in case you want to see how the x is disappearing. So when you cross multiply, we have dy dx is equal to 3y ln 6. So this can be simplified further by writing it as ln 6 to the power 3y. Then the final answer will now be equal to ln 6 to the power 3. The value of y is simply just the whole expression, this one, which can also be written there as 6 to the power 3x minus 4. Don't make a mistake by multiplying these 3 and 6 there. Okay, let's quickly move on to this one. So when I do this one, it means that I've done this one, it means that I've also done this one. So I'll do this one, then we'll see if we can also do this one and this one. So for f of x is equal to x times 9 to the power x. So differentiating this part will require us to use the product rule, because we have two functions that are multiplying themselves. And then differentiating this part is straightforward. So what we can do here, we can introduce ln. So when introduce ln, we're going to have ln f of x is equal to the ln of, and then we have x times 9 to the power x. Remember, if you have two functions multiplying themselves according to the rules of logs, we have ln f of x this side. This one can also be written as ln x plus ln 9 to the power x. So we can drop down the x so that we have ln f of x this side, and then this other side we're going to have ln x, and then we have plus x ln 9. Then differentiating this part, we're going to have 1 over f of x, then we're multiplying this with f prime of x is equal to, then when you differentiate ln x, the answer is, you differentiate this part, you get 1, then divide by the original function, which is x. Then this other part, differentiating it, remember ln 9 is just like any number, so we differentiate this expression in the same way we can differentiate 2x. So 2x gives us 2. So this one will also just give us ln 9. So we're going to say ln 9. So now after differentiating this, we can now multiply everything by the, we can now cross multiply so that we can leave f prime of x along this side, which will give us f of x multiplied by 1 over x, then plus ln 9. So this will now be equal to, so f of x is simply just x times 9 to the power x. So we're going to have x times 9 to the power x, then multiplied by 1 over x plus the ln of 9. So this can be simplified further by multiplying this expression with everything in brackets there. If you want, you can do that. Yeah, but you can, actually you have to do that, which is simple and straightforward. Okay, this one, the same way I've done this one is exactly what you do on this question. So you can solve it and see if you can manage. And then let's also look at this one. So when you look at that question is a function of t. So don't get confused because of the r that is there. So consider that as just a constant, because this function, according to the to the function there, this is g of t, meaning it's a function of t. So when differentiating this function, we'll just look at t alone, we'll not look at this other part. So given g of t as t to the power 2, then 2 to the power r, then they ask you to differentiate this expression with respect to t. So differentiating this function with respect to t, you just have to say g prime of t is equal to, when you differentiate this with respect to t, 2r is a constant, so it has to remain like that. Then differentiating t to the power 2, you're going to get 2t as your derivative, because you say 2 times the coefficient of t here is 1, it will give you 2, and then t, you have 2 minus 1 there, which will give you t to the power 1. So when you simplify this expression, you can write it as g prime of t is equal to, since you have this t, this 2 and that 2 multiplying, so you can say 2r plus 1, then times t. This is how best you can simplify it. Let's quickly move on. Let's see if we can solve another one. So for this one, it's straightforward as well. You just use the quotient rule. You can also do it and see if you can get the answer. And then even this one here, I'm going to use the product rule, or if not the product rule, or if not the quotient rule on this one, you can just introduce ln. When you introduce ln on this one, okay, let's do it together. So we have f of t is equal to 2 to the power t over t. So when you introduce ln on both sides, you have ln f of t is equal to the ln of 2 to the power t over t. So you are going to have ln f of t this side, then this other side you have ln 3 to the power 2t, and then since you are dividing this function, you say minus ln t. So differentiating this part here is also straightforward. What you do is you can first differentiate this expression here, or before you do that, you can first drop down the expression there, which is the power. So when you drop down the expression, you are going to have ln f of t is equal to 2t ln 3, and then minus ln t. So now we can differentiate this because it's now straightforward. So we can say 1 over f of t and then times f prime of t is equal to, when you differentiate this part, you're getting 2 ln 3, and then differentiating this part, you're getting 1 over t. So this is what you get, yeah, after differentiating. Here we can now cross multiply so that this f of t comes the f of t comes that side. So to remain with f prime of t this side, you're going to have f of t multiplying everything with a 2 ln 3 minus 1 over t. Then from there we can simplify the whole expression. This will be, so while there's f of t there, we can replace back with this function, which is 2 to the power t over t multiplying 2 ln 3 minus 1 over t. So this is exactly how you solve such an expression. So let's quickly move on to the next question. If you have not yet subscribed to the channel, make sure that you do so, and don't forget to click the notification button. If you have any questions, feel free to contact me on any of these lines on the screen. My name is Harmtedy. See you in the next tutorial video. Shalom, shalom.